So in the next two videos, we're going to start looking at getting the angle between two lines. Before we start on that, we're just going to look at, again, at the slopes of lines. So before this, we said the slope was equal to y2 minus y1 over x2 minus x1, or else the slope could be the rise over the run. Well, there's one more thing that the slope can be, and I'll just scribble it in here. So the slope is equal to tan of alpha, right? So this is the new one, where alpha is the angle it makes with the positive x-axis, as I have labeled in there. Yeah, so it's not any of the other angles, it's always this one here. So if you find that angle alpha, you stick it into your calculator as tan of alpha, you can calculate the slope. So it'll give you a number like 1, minus 2, etc, etc, etc. I'll just scribble in here that alpha is equal to the angle with positive x-axis. Yeah? So we need to know that first. And now we can start looking at angles between two lines. Yes, so this is just a small kind of prelim first. So I will draw one line here, and I will draw another yellow line like this here. And we're going to look at the angle between them. I'm going to put it in red. So I'm going to call this angle theta, which you've probably seen before in like trigonometry and stuff. So they use that. It's a Greek letter they use for angles all the time, okay? So it's pronounced theta. Not that really matters. But there's a formula for getting theta, which you do want to do sometimes. So the formula is tan of theta is equal to plus or minus m1 minus m2 divided by 1 plus m1 m2. So put a box around that. That's going to be an important formula. So that is in the tables book. And the reason it's plus or minus is because there are two possible angles theta. So that's the angle between the two lines, but so is that as well. So depending on the plus or minus, you'll either get the acute angle or the obtuse angle. Okay, so I'll say acute is equal to the small angle, and the obtuse is equal to the big angle. Yeah, so depending on plus or minus. So if you get 135 degrees, you know that that's just that one, and then to find the smaller one, you just say 180 minus 135 as an example. And also, sorry, I don't think I mentioned that M1 and M2 are the slopes of the two lines. So for example, in this case, M1 and M2. So you have to calculate those slopes first, and then you can find the angle in between them. Does that make sense? So we're going to look at just a quick basic example question. So here I have it scribbled out quickly. It's asking us to find the angle between this line here, 2x minus y plus 5 is equal to 0. And this one here, 3x plus y minus 7 is equal to 0. So if we look at the formula, tan theta is equal to plus or minus m1, m2, m1, m2. Basically, that's what we need to find. We need to find m1 and m2, and then we can find theta easily enough. So I'm going to call this slope, or this line 1, and this line 2. So we'll start with 1. We have 2x minus y plus 5 is equal to 0. The slope is equal to minus a over b. So in this case, it's minus 2 over minus 1, which is just equal to 2. So that's fine. And then I'll go bright blue, which is number 2. And we're going to have 3x plus y minus 7 is equal to 0. In this case, the slope, again, is equal to minus a over b, which is going to be minus 3 over 1. So it's going to be minus 3 as our answer. Yeah, so now we have the two slopes. I'm actually just going to label that as m1 is equal to 2, and then I'll say m2 is equal to minus 3. m2 is equal to minus 3. So I'm going to write out that formula again. I'll go yellow. So we're going to have that tan of theta is equal to plus or minus m1 minus m2 over 1 plus m1, m2. So now we're going to start subbing things in. So it's going to be tan of theta is equal to plus or minus m1, which is 2, okay, minus m2, which is minus 3, so careful of that, minus minus, divided by 1 plus m1, which is 2, multiplied by m3, which is minus 3. So we're going to have tan of theta is equal to plus or minus 2 minus minus 3, which is 2 plus 3. So that's going to be 5. And 1 plus 2 multiplied by minus 3, that's going to be minus 6. So we're going to have minus 5 on the bottom. Just scroll down a little bit more. So that means that tan of theta is equal to plus or minus of minus 1. And that actually, funny enough, becomes that tan of theta is equal to plus or minus of 1. Right, so we'll put a box around that for now. The reason that is, if you have minus minus 1, that'll be plus 1. And then plus minus 1, it'll be minus 1. And you'll still end up with plus or minus. Or you could say minus plus, but it's the same thing. Yeah? So now we have to find theta. Okay, so we're going to split it up into two things. I'm going to say that tan of theta can be equal to plus 1, or else tan of theta can be equal to minus 1. Yeah, because it can be plus or minus 1. One of them will give us the acute angle, one of them will give us the obtuse angle, or else in other words, one of us will give us the small angle, and one of them will give us the big angle. Scroll down. I guess I'll change color just to mix it up. So in this case then, theta is equal to, sorry, I have to erase that quickly. Theta is equal to the inverse tan of 1, and here we have theta is equal to the inverse tan of minus 1. So that means in this case, theta is going to be 45 degrees, and in this case, theta is equal to 135 degrees. So those are our two angles. We have our obtuse and our acute, or else our big and small angle. So hopefully that makes sense. Just I'll give a quick brief overview. So again, we're getting the angle between two lines. You can call the slope of a line. You can get it by saying tan of alpha, where alpha is the angle with the positive x-axis. So here, two lines intersecting, you're going to have a big and a small angle. So say this line has M1 and M2, then your tan of theta can be got by saying this formula here basically. So if you want to find the angle between two lines, again, the main point is you need to find their two slopes and then put it into this formula here. And don't forget that you're going to have a plus or minus, so you're going to get a big and a small angle. So hopefully that all made sense, and we're going to look at a difficult example where they use this formula here in the next question. We'll see you then.